It's wonderful to see everyone here today. My name is Naslin Howell. I'm Emeritus Professor of Food Biochemistry at the University of Surrey, UK. I'm Director of my SME company, NK Sustainable Bioproducts, which is part of this INNOECOFOOD project. And I'm Joint Research Coordinator of INNOECOFOOD. I would like to extend my very warm welcome. I think I might share the program, which I was going to do. How to expand it. I'm trying to expand this thing. Okay. Okay, can you see that? Yes, okay. So I would like to extend a very warm welcome to all the participants. Thank you for joining this conference, which is entitled Enhancing Sustainable and Resilient Agroecology. The seed for this conference was sown over 2 years ago, whilst I was writing the proposal, and I got in touch with the coordinators of TRANSECT, agroecology, TRANSECT and D4AgEcol, as it was an EU requirement for us to collaborate. And we decided then that the best way forward was to have a joint conference. And here we are after over 2 years, after getting the grant and 18 months into our INNOECOFOOD project, the joint conference has become a reality. So I thank you for your cooperation and your support to everyone who has enabled this conference to take place. Whilst the 3 cluster projects share a common goal in enhancing sustainable and resilient agroecology, we have different approaches, which are based on geography, culture, nutritional status, and level of economic development in all our different countries. So discussion through this conference will hopefully spark new ideas and lead to further innovation and beneficial research for all 3 projects. So the structure of this conference is based on 3 common themes or sessions. Session 1 is about sustainable approaches in agroecology and food processing. It addresses climate change and includes resilient farming methods, biodiversity, sustainable feeds, and food and waste reduction in order to promote circular economy. The second session is on digitalization, tools for sustainable agri-food systems, and this will exploit the latest developments in terms of AI and IoT, data collection and handling, drones, software to analyze greenhouse gases and energy, and sensors for sustainable and efficient production and processing of food. We're also looking at the quality of food but not everything is covered in this conference, I'm afraid, because of time limitations. The third session is strengthening the community and stakeholder engagement in sustainable agri-food development. And this will explore engagement with the community, farmers, policymakers, researchers, and NGOs. In terms of the timing, each session will have selected speakers who will speak for about 10 to 15 minutes. Everyone knows how much time they've got. So at the end of the session, there will be a roundtable discussion. And this will also allow others to contribute to the discussions if they would like to. Please post any questions or discussion topics on the chat, and Mariana has kindly agreed to monitor the chat and will read out the questions during the roundtable discussion. So let me begin by welcoming our three coordinators to give introductions to their projects. Is Antonio here?
Yes, I am, Naslin.
Oh, great. So I can announce you as the first speaker. Okay, so first we have Dr. Antonio Marques of CIMAR, Portugal, and he's the project coordinator of INNOECOFOOD. And thank you, Antonio. Please go ahead. I will stop sharing so you can.
Okay, and I will start sharing my presentation. I think this is the one.
I don't have biodata for anyone, so please introduce yourselves. Thank you.
Can you all please tell me if you are seeing the presentation properly?
No, you have to make it full page, press that icon on the left and top left.
Wait.
We can see it, but it's not full screen.
Okay, then.
It's the, yes.
And I will put like this, sorry. I'll put already in presentation mode.
Okay.
Sorry. Sure, what is? How can it be that it doesn't want to start? Again. Okay. I think it's the same.
Oh. You got wrong one.
Don't worry, Naslin. We will work like this.
This is fine. This is fine. We can all see it.
Okay. Probably you have the notes, but there is no notes. Well, first of all, it's a pleasure and an honor to be here and to host or to co-host this conference together with Agroecology TRANSECT and D4AgEcol consortiums. This is something that the European Commission has enforced, but I think it's in a very good way because this promotes discussion among the different perspectives of the different EU-funded projects. What I'm going to show particularly to agroecology TRANSECT and D4AgEcol is what is INNOECOFOOD project. Basically, this project has started in 2024 in January and will last 36 months. And it focuses on the development or implementation of technologies, eco-innovative technologies, for improved nutrition, sustainable production and marketing of agroecological food products in Africa. And again, this does not work. Okay, now it's okay. Why INNOECOFOOD was built? First of all, we are all aware that the global population is increasing a lot, and this leads to the need of food all over the world. And in parallel, we assist that 1/3 of the food that we produce is wasted, and also more than 2 billion people is affected by food insecurity all over the world. Particularly Africa is affected by hunger, more than almost 300 million people, and almost 20% are undernourished in Africa. So they are severely affected by food insecurity. And aid is not the long-term solution. What we need is to empower African people to be able to produce nutritious food that is not only sustainable, cheap, but also is able to mitigate hunger and malnutrition, and at the same time enabling them to be autonomous in creating employment and in improving livelihoods of rural people. Here it is the concept of the project that I don't know if it works or not. This was the video of the project that we had. So I will skip this, but basically how INNOECOFOOD was built. So there are problems in Africa about the distribution chains that are disrupted, difficulties in producing energy, stable energy support for the food chain, and in 4 different countries, particularly in Ghana, in Kenya, in Tanzania, and in Egypt, we are building eco-hubs. This is the aspect of the eco-hubs. This is a hub where fish, particularly tilapia and catfish, can be produced. All the life cycle can be produced in the same place, together with spirulina, highly nutritious spirulina, and insects, particularly crickets and black soldier fly. And in the nearby, we have processing facilities where we can process the food that we are producing, fish, insects, and spirulina, and create products that can then be sold in stores nearby for the local communities. And in parallel, we train the local communities to replicate the concept. This is the concept of the eco-hub that we are building in these 4 countries. And these eco-hubs are being built in a way that they are certified for the good manufacturing practices, for hygiene practices and HACCP, that then will be required to ensure that safe products are delivered to the market. But not only that, also they are built in a way to alleviate the carbon footprint of the products that are being produced and using circular economy. So reducing the amount of waste and utilizing the waste that are produced from one food source to another. In terms of technologies, we are using solar powered equipment like ice making machines to produce ice using stable energy sources and renewable, and also solar multi-purpose dryers to dry fish, spirulina, insects, and novel products. Together with the artificial intelligence and IoT, we are introducing sensors all over the production and processing chains to be able not only to control, but to monitor and to regulate the systems for the production and for processing. In this way, we have data that helps the producers of the eco-hubs to better manage the facilities. But we also tackle the circularity. We do not only produce fish and spirulina and insects, but we use the co-products that are also released from this production, and we create added value products, like for example cookies from fish co-products, also cookies here in this case for spirulina, and bread from insect powder. So in this way, we have a full circular economy with zero waste and optimization on the utilization of water, which in some countries are very scarce. But innovation in INNOECOFOOD is not only focused on development of products, but also is community-oriented. We are training in an innovative way 30 women and 30 youth as trainers of trainers. This means that they will be embraced in training of the methods of production and processing in the value chains of the eco-hubs in order to then to train in their local communities, and together with digital tools of training, we expect to impact at the end of the project more than 5,000 community members. And the concept of the eco-hub is to run in parallel as a public and private business model, where the trainers will be trained in terms of business skills and marketing. And the purpose is to develop and replicate this concept of the eco-hubs into viable business models once the project ends, in order to ensure that we have affordable, healthy, safe food for the local communities everywhere in Africa and elsewhere. But this is only possible with 20 partners that are fully engaged from Africa and from Europe, that are fully engaged to ensure that the projects are accomplished. And so far, we are in the good way to accomplish in due time all the objectives that we have set. And that's it from my side.
Oh, thank you, Antonio. That was perfect timing and very, very succinct summary of the project. Thank you very much.
Thank you.
So I would like to invite the next speaker, Dr. Bertrand Dumont from INRAE of France. And he's the coordinator of agroecology TRANSECT. And I'll leave you to introduce yourself and tell us more about your project.
Thank you, Naslin. Can you see something on the screen?
We can see your presentation. We can hear you well.
Okay, thank you. Thanks a lot. Thanks a lot for giving us the opportunity to join this cluster event. So I'm Bertrand Dumont. I'm a senior scientist at INRAE, which is the National Institute for Agronomic Research in France. And I'm an animal scientist by training. But I've long been working on grassland-based systems. So I've developed interdisciplinary research, especially with people working in ecology and on the environment, and more recently with people working on participative science. So we were funded in the climate call. We started nearly 3 years ago, and we will end in August 2026. And TRANSECT means transdisciplinary approach for systemic, economic, ecological, and climate change transition. So it means that our overall objective indeed is to contribute to unfolding the full potential of agroecology for European agriculture by developing robust evidence of the positive effects of agroecology on 3 dimensions: on climate change mitigation and adaptation. The second dimension is biodiversity in agroecosystems, and the third dimension is farm socioeconomic resilience. So you see from this first message that we will try to develop multi-criteria assessment of the different farming systems. We have identified a number of users of our research, and these users are farmers, farm advisors, also NGOs, and different policymakers, decision makers. And agroecology TRANSECT will provide these farmers, advisors, NGOs, and decision makers with knowledge on the key enablers and barriers to actual uptake of agroecology at farm and territory levels. And doing this, we will contribute to a dependable knowledge base for EU policy design and implementation. And this objective will be achieved by a number of tasks, but here I'm reporting 3 key tasks: fostering local co-created knowledge by engaging in real-life agroecological context. And I will show you that we indeed mobilize the knowledge that is being produced by local stakeholders in 11 innovation hubs. We use the term innovation hubs, but you can consider it as the same as living lab. We will also review the definitions of agroecology in relation to other sustainability concepts and characterize the narratives that frame agroecological social movements in Europe. I will give you some elements on that later in the talk. And we will provide locally relevant tools and indicator frameworks that allow monitoring of progress towards the Green Deal objective, which is part of the European Common Agricultural Policy. So this is the map of our 11 living lab, or our 11 innovation hubs. And these innovation hubs were selected because at the start of the project, they were already engaged in agroecological transformation, and they agreed to team up with us for 4 more years. And they are supposed to represent the diversity of European agriculture. And I should feel ashamed today to tell you that indeed, in none of our innovation hubs we did with aquaculture. We have some aquaculture in the Danube Delta, but our innovation hub indeed focuses on organic crops. So within our networks, we have 3 grassland-based systems in French Massif Central, where I'm living and working. These are uplands in Switzerland and in Bulgaria. We have 4 annual cropping in Denmark, Netherlands, Belgium, and Romania. And some of these are organic. Some of these are also referred to the framework of conservation agriculture. We have 2 integrated crop livestock systems, one in Andalusia in the south of Spain, and Elisa this afternoon will tell you more about what they are doing there. And the other one is in French West Indies in Guadeloupe, and we are working with very small family farms, highly diversified farms in a tropical context. And I hope it can also facilitate to make links with the tropical world. In Hungary, we are dealing with vineyard and orchards, and especially this living lab is focusing on the benefits of cover crops in vineyard and orchard, also to limit soil erosion and to preserve soil quality. And last but not least, in Slovenia, we are working with a small medium enterprise that is delivering organic vegetable boxes to the inhabitants of Ljubljana, which is the capital of Slovenia. And they are also a knowledge hub for organic farmers. So this is the 11 innovation hubs that are central to the project. But of course, they are not only innovation hubs. We have a total of 19 partners from 12 countries. You have already discovered 10 countries. The other 2 are Germany and the UK. And among these 19 partners, 10 are academic partners, and we have a balanced expertise in agronomic science and ecology on the one hand, and on political and social science on the other hand. And we have 9 non-profit organizations or small and medium enterprise. We are very engaged, provide a gender balance in the management of a project, but also to analyze in some innovation of the benefits of agroecology also for women. And we're also very engaged to offer opportunities for your researchers. And you will hear later Adrien and Stephen, who are 2 from our young researchers. Of course, even if these 11 innovation hubs are central to projects, they have a central place, but we analyze more broadly the narratives and opportunities for the development of agroecology in Europe. And an example is that the factors of success or failures of agroecology have been analyzed in a total of 89 dynamic agroecological initiatives that are in 23 European countries. And also we analyze the narratives of 115 social movements. Some of them, the figures are less than 115 because some of these social movements are European or international, but you see that they also cover 23 countries. And I will just give you one example of this work where we aim to characterize the narratives of these social movements. We were interested in how they relate agroecology to biodiversity, climate, and resilience, but also the points on which there are some warning signs or to which they are opposed. And usually there are warning signs when they consider that there's a vague approach that shares some farming practices with agroecology that fail to point the need for food system transformation and address the root cause of a problem. And it just to mention that digitalization is one of these warning points, and which call us to think on, and that's why we're also happy to talk to you today on what would be a digitalization that is compatible with the values and principle of agroecology. And so far, we discussed within our innovation hubs that we think we would favor low-cost options. This picture comes from Africa, I guess. You see that it's possible to track some of the animals to see where they are grazing or browsing. And also on the smartphone, you can receive information on where it has been raining. And these are low-cost options that can facilitate the life of shepherds. So I told you that we don't have a lot of aquaculture. We don't have any aquaculture. We don't have a lot of digital science. So why to talk to you today? I hope we can anyway bring you some information that you will find useful, because I think that we are developing interesting frameworks and also interesting methodologies that could be used by others. Our goal is to create locally salient knowledge while using generic scientific knowledge to enhance local capacities. And this is one of the frameworks we are using to analyze transition. It has been proposed by Gilles in 2002. You see in the middle that this is the dominant socio-technical regime. We call it, Gilles call it a multi-level perspective, because you see that this dominant socio-technical regime is influenced by market, by user preferences, by industry, policy, knowledge that can be technological or more scientific, and also by culture. And our innovation hubs are considered to be niche innovations in blue on this figure. And sometimes the socio-technical landscape, what citizens think, what consumers want to buy, also opens room for opportunity for this niche innovation to anchor into the dominant regime. So anchoring can be defined as how niche link up to this dominant socio-technical regime. And what you can see here is that some of our innovation hubs are indeed closer to the dominant socio-technical regime. This is, for instance, the case of our Danish innovation hub, while some of those are more opt for more radical options and are further away from the dominant regime. This is, for instance, the case of Spain. And sometimes it's even more complicated. This is how we represented Belgium. ASI is for conservation agriculture, and AB is agriculture biology, is organic farming. You see that when considered alone, they are quite close to the dominant regime. But while you combine organic farming and conservation agriculture, this is a ABC, this is very far from the dominant regime. And you see that we have therefore diversity within our innovation hubs, but also between the innovation hubs, and we want to learn from this diversity. I don't have time to say more on that, but I would recommend, if you are interested by the question of barriers and level to agroecology, is to connect to our YouTube page. You've got the link at the bottom of this page, because we already provided the first transversal analysis of barriers and levels in the 11 innovation hubs. And we also had heard the voice of 3 of our innovation hub facilitators in the Netherlands and Spain. Elisa, you will meet later, and Alexandra in Slovenia, who's developed this green box with organic vegetables in Slovenia. So they will explain in this video what they consider to be the main barriers and the main levers to scale out agroecology. Also, something we are analyzing is which agroecological principles are being mobilized in our 11 innovation hubs. I guess that some of you are familiar with these 13 principles that have been proposed by the high-level panel of experts of the United Nations on nutrition and health. And this is the framework we are using. Those at the bottom are more ecological or agronomic, those at the top are more social. And you see that synergy and co-creation of knowledge have a central role in this framework. And what we have done so far is that we have analyzed the relative importance of these 13 innovation agroecological principles in our innovation hubs. I'm here presenting Switzerland, France, and Spain. And you see that though we could observe activities related to each of these 13 principles in each innovation hub, their relative importance differ among innovation hubs. And therefore, we can conclude that such contrast highlights how agroecology is giving space to different equilibria among principles, which makes sense indeed for a concept that calls to adapt to the needs of farmers and local communities. And something also very interesting that already emerged from our results is that when we analyze the narratives of social movements in Europe, we indeed realize that out of 115 social movements, half of them or nearly half of them did not have any clear definition of agroecology. And for the remaining one, only 15% of this remaining one referred to this high-level panel of experts principle, which are closely related to the elements of agroecology proposed by the FAO. But it's also a minority of social movements that use this framework. So we realize that we are not talking exactly the same language that social movements. And social movements, indeed, I'm going in the wrong direction, indeed refer to the Nyeleni Declaration for 70% of them. And the balance of principle in the Nyeleni Declaration is more towards the social principles. And that's why we put in the debate 4. So they have 11 pillars. They don't call them principles, they call them pillars. But we put 4 of these pillars in the debate: how to transform power structure, what are the spiritual and non-commodified connection of farmers to the land, one on women's rights, and another one on ecological and low input, which is one of the few ecological pillars. But what is said in this pillar is that in agroecology, we should not use any agrotoxics and GMOs. And so we engage the dialogue on agroecology within Innovation Hub Network. And it's really on this point of no use of agrotoxics and GMOs that we had the strongest debate with some people who strongly disagree with that, while especially those who are close to the dominant system, while others agree with that. And we try to make progress in this dialogue on agroecology to see what is conflicting and what is not conflicting. So I'm coming to the end. Just my last idea is that we not only focus on what we learn, but we are also interested in how we learn. And Stephen will tell you more on that later. And in the description of action of a project, we have developed a theory of change. The theory of change explains why we do what we do. And this results in action plans. Actions plan describe what we do. And this ends with a learning history. Analyze in a reflexive process what we have learned from the last all things that have been happening in the different innovation hubs in the last 6 months or in the last year. And these are learning loops. After thinking on what we have learned, we propose a new action plan. We do it, and then we already, again, have this reflexive vision of this. And indeed, you see these learning loops going on through the project. And we have indeed 5 co-innovation workshops where all the 11 innovation hubs meet and learn together, share their experience, and these are really important events for our project, really to spread the knowledge, to learn from the others, sometimes to think out of the box when you interact with someone who's working on a very different system. So I think I'm a little bit too long, so I will conclude. Just to tell you our 3 presentations today. 2 are related really on the methods and approach, because I think this is where we can bring you the more information. And the 3rd one will be on strengthening community and stakeholder engagement in the case of Inspira Territorio, which is our innovation hub in Andalusia. I encourage you to keep track with our work by connecting either to our websites, and we are also on 5 social media, already mentioned YouTube. And I also inform you that if you go to the events page of this workshop, we have frequently webinars, and the webinars can be attended live. It's of course free. And then we share the webinars on our YouTube page, and tomorrow we have a webinar on gender in agroecology to identify structural barriers to leave more place to women in agroecological system. You can still register. Thanks for your attention.
Thank you very much, Bernard, for a very clear and interesting presentation, showing us the advanced approaches you're using and to widen agroecology in Europe. And all the challenges you're facing and the achievements you've made. Thank you so much. So I would like to invite the next speaker. He's the project coordinator of D4AgEcol, Dr. Andreas Meyer-Auric from ATB Potsdam. Can you stop sharing, please?
Thank you, Nazanin. Oh, I have to stop?
Oh, no. I thought that was
That's mine.
Bertrand. Oh, it's yours. Great.
Yeah. Thank you,
I saw
Nazanin.
agroecology TRANSECT and I thought, oh.
No. So thank you for this initiative, and so that we also can contribute to this conference. And yes, we are also a Horizon Europe project, as you nicely also introduced already, working on digitalization and agroecology. Our focus is a little bit more on digitalization, but also, of course, in the context of agroecology. And I think these different aspects can bring can contribute to a holistic picture of everything. We have also no focus on fisheries and much on arable cropping, and but I can also now show you more about this. To my regarding to my person, I am an agricultural economist, and yes, and I'm coordinating this coordination support action for almost 3 years already, and we are now already going towards the end of our project, which will end in August this year. And so I would like to share some insights from our project. And yes, first of all, yes, these are our partners that are spread all over Europe, and from Finland to Portugal and UK to Cyprus. And yes, and as I said, it's a coordination support action. So our primary aim is to provide guidance for policymakers and also actors in to contribute to advanced regulation to harness the potential of digitalization for agroecology. That is the primary aim of our project. And so what we see digitalization as an innovator for agricultural systems. And so clearly GPS and GNSS started some decades ago to start this process, but now in combination with sensors, robots, and drones, very much advanced systems are now in place, which go far beyond to form a precision farming approaches, which only tackled site-specific aspects. And the question now is, to what extent does this also contribute to the need for the transition to agroecology? And this is the focus of our work. And so our question, the driving question for us, is how can digital tools and technologies help in this context? And what we do here is we want to learn from success stories. So there are some success stories. For example, in Bavaria, there's a robot that has been sold more than 20 times that can automatically seed and weed in sugar beet production based on solar energy, and this can enable organic farming systems with sugar beets. And this we have seen as such a success story, which we investigated a little bit further. And so just as an example, and and like this we sorry, I have to stop this. Like this, we had to we were looking in 10 different living labs in 7 different countries at specific digital tools and their impacts on agroecology. We did that with different stakeholder groups, and in fact, what we did, we had a split work on this. On the one hand, we looked on the impact of technologies on agroecology, and on the other hand, we looked on the adoption potential of this technology to see also what potential impact we can expect from these technologies. And as Bertrand has also already mentioned, we are strongly related also to the 10 elements and also to the 13 principles. But in our work, we focused very much on the 10 elements of agroecology based on the FAO. And so we elaborated on indicators for these elements, and with the stakeholders tried to identify to what extent the technologies we looked at are compatible with the elements of agroecology in this case. And what we did in this other group is where we focused on the adoption potential of the technology. There we use the ADOPT model, which is an empirical model, and with based on 22 questions, we were able to estimate a prediction about the time of the peak adoption and also the peak adoption level of specific technologies that we looked at. And so this is an overview of the technologies that, or the living labs that we looked at, where we looked at the specific technologies, also again spread over all Europe. And so some impressions here. For example, we looked at technologies at the high TRL level. So there's, for example, the Yara N sensor, and which we analyzed in a workshop in Potsdam. And also in UK, we looked at retrofitted autonomous strip cropping systems, and also in animal husbandry, we looked at virtual fencing systems, where which is in no fence technology, meaning that animals can can graze without a fence in the landscape, and this navigated with a system with collars which hinder the animals leaving a specific area where they shall graze. Just to give you some impressions of what we are looking at, and so to give you some insights about some results that we gained until now. That is, first of all, we found that, which is quite obviously, that digital tools can contribute to more efficient use of resources, and so to a higher efficiency and lower input rates and lower emissions, and regarding other aspects like participation and co-creation, of course, this differed a lot across the different technologies that we looked at, and also and these other aspects like diversity, social and human values. We have found that there are still a lot of knowledge gaps. We don't really know what the impacts are here, and we see here more research that is needed. And we also looked at some rebound effects that are possible using these technologies. So, for example, technologies on fertilizer can increase the demand for fertilizer use, and then could lead also to an increase in application rates, and so which could be a negative effect. Also, increased homogenization of areas could be at the expense of biodiversity. And also, we found that for some technologies that recycling aspects were not taken into account, so that many technologies are much material intensive in a way. And well, and as I said before, is also here regarding diversity, social and human values, we still do face a lot of knowledge gaps here, which deserve some further attention. And regarding the adoption potential, just wanted to highlight here at the example of this solar-driven robot. We identified, for example, with our technology that which are the factors that mostly drive the adoption. That is, for example, the ease and the convenience of the technologies, and also aspects like trialability are very important. And we came to, at this example, to an peak adoption in 16 years, where we estimated that 28% of the organic farmers in Bavaria would adopt this technology. And if we now then compare this also with the other technologies we looked at, you can see that some technologies will probably be adopted earlier than others, and so that can show the driving forces that may drive also the change in digitalization in agriculture. So all of this goes into a policy roadmap on digitalization as an enabler for agroecology. And for this, we had national stakeholder workshops in 7 countries already, and we are now planning a European stakeholder workshop or European policy workshop on the 23rd of June, which is announced also on our website. So if you're interested, you're heartily welcome to participate. And as an outlook, our project is running 3 more months, and so there are still open questions and policy needs. Regarding the policy needs, we'll work on that in our European policy workshop. And yeah, so yes, and here maybe also I want to point out again to our European policy dialogue. As I said, you are all invited also to register for this. And with this, I want to thank you for your attention.
Oh, thank you so much, Dr. Andreas, for a fascinating insight into all the advances you've made in your innovative tools and technologies. And I'm sure that will also be very useful for us sometime along in the project. So thank you. So I'm aware that we have to move on because the next speaker is Stephen Lighthizer from agroecology TRANSECT. He needs to get away, so we've slightly changed the program. So he goes first. And we're beginning the first session on sustainable approaches in agroecology and food systems. So we'll start off with Stephen Lighthizer. So I don't know if you want to share your slides, please. Stephen, are you there?
Yes, I'm here.
Oh, great. Thank you.
I hope maybe you can see my screen now. Is that? Oh no, I still have to click here. It should be there now.
Now we can see it. Thank you.
Great. Okay. All right. So yes, thank you, everyone. And Bertrand already introduced our project a little bit. He gave the bird's eye perspective from the coordinator. And now, as he mentioned, I will talk a little bit more about our ways of working in the project and some of the methodologies that we use with innovation hubs for pursuing transformative change towards agroecology. And first, I want to start by just sharing some of the guiding ideas of the project. So the project is envisioned as another way to manage and implement multi-actor projects, which are increasingly popular. So we start with this idea of multi-actor projects as a temporary travel companion. So that means that, we are with the innovation hubs for a limited amount of time, and we want to make the most of that time. And we start by this principle of thinking in the long term. So again, acknowledging this interaction will end at some point, and we want to act in the short term, but with the idea of creating a legacy beyond the project's lifespan. And we also, in this action in the short term, want to work with the innovation hubs to create knowledge, produce knowledge that is locally salient for them, so that's relevant and useful for the actors. And use the generic scientific knowledge from scientists at the work package level to enhance these local capacities of innovation hubs. And this, in turn, should enable anchoring, as Bertrand, I think, mentioned already a little bit, to allow agroecological initiatives and innovation hubs to become more durable over time in their places. And the way that these ideas, these guiding ideas, are implemented into an overarching approach or methodology is through this concept of co-innovation that has been used now in several projects in Europe and in Uruguay, going back to 2011. It's based on 3 pillars, you could say. The first is the point of departure is a complex adaptive systems approach that is supported in the project by monitoring and evaluation and the creation of social learning spaces in the project with the innovation hubs, with the societal actors. So the overlap of the complex adaptive systems view and the monitoring and evaluation is this adaptive management, changing things on the fly if necessary. And then, the social learning mixed with this complex adaptive systems view impacts how we see the world and framing, so we learn in that way as well. And then the monitoring role is not about accountability necessarily, but it's monitoring for learning. So we do it with these societal actors and with the work packages to ask these questions. Are we doing the right things? Do we need to make adjustments? And this overlap of all these different pillars is the co-innovation. So that is the overarching approach that we take in the project. And we have an entire work package that's dedicated to this approach, which is another unique thing about agroecology transect. And as part of this learning cycle that we do, I think Bertrand mentioned already, we have a learning cycle each year where we develop a theory of change, an action plan, and then we reflect on that in the learning history. As part of this cycle, the work package 3 that I'm a part of has defined 3 aims. So the first is to create a transformative learning process for the participants, then to foster development of actionable knowledge to support actors to achieve their missions, and finally to evaluate the effectiveness and the mechanisms of the approach that we use. So that's the work I'm involved in. Just to give you a bit of an idea of what this learning process looks like, this transformative learning that we try to engage in, we have co-innovation workshops, which we can think of as social learning spaces. And basically what these try to create in the project is regular structured dialogues where we bring together societal actors and scientists, supported by this reflexive monitoring. And this process should foster the building up of trust and social capital between the actors. And these together, this social learning spaces is seen to produce the necessary ingredients for that actionable knowledge that we try to generate. And what do these co-innovation workshops look like? These are just some pictures. So we follow this peer-to-peer model. We try to facilitate as much interaction as possible. This includes farm visits to the local innovation hubs. It also includes a lot of different formats and ways to structure these dialogues. And these workshops are focused on the one hand about responding to the needs, the practical needs of each innovation hub, but also we have moments of learning together as a consortium. And just to, again, go into a little bit about this learning cycle, it's rounds of action where we make plans and we implement actions. We then observe the effects of these actions and then reflect on and analyze how this has gone. Is it contributing to our mission, our intended effects? So the observation includes things like most significant events, action types and effects. And then we also reflect on the bigger picture. So what are the enablers and barriers to what we try to achieve? And what are the contributions that we're making to transformation? In one paper that I'm working on now and leading in the project that I just want to highlight here is this third aim that we have in the work package 3 is evaluating our theory of change. So we use an approach called realist evaluation, which basically simplifies the theory of change in the project. That is the first hypothesis, you could see it as, is that we are creating these social learning spaces to support actionable knowledge, and that this will lead to transformative change or contributions to transformative change. So that's the evaluation that we undertake at the moment. And I just want to share some initial results from that process to show you, on the one hand, some of the outputs that we generate, but also on the other hand, some of the challenges. So in terms of, something's a little bit wrong with the slide here, but there we go. So in terms of actionable knowledge production, we look at it in terms of conceptual actionable knowledge, so new ways of thinking, new ideas. And we see that the actors in innovation hubs have gotten new topics to work on, new approaches, new styles of doing things and new ways of thinking. That has been something quite widespread across innovation hubs. Also, instrumental actionable knowledge is something that's more leading to direct changes in actions. So in the Netherlands, we had an example where the project enabled the innovation hub to get their practice of strip cropping involved in the Dutch eco scheme. So this gave a huge increase in their participants from 50 to 400, and their time and resources were the key mechanisms. And also, providing input for scientific discussions and debates in the public. So we see already in the short time that we've worked together many outputs here. We've also seen challenges that emerge from this process, and the idea is not to focus on these challenges as insurmountable barriers, but to learn from them for next projects, future collaborations. The first that I would mention is that it's a time-consuming process. So a statement from one of our innovation hubs is that, yeah, this approach, inter and transdisciplinarity, it sometimes conflicts with the fixed framework of projects, contract end date, and the milestones, deliverables. So that's a challenge that can also be influenced by changing research policy and funding arrangements. So these are recommendations that we make as well. And there's also, different needs and interests between science and societal actors at times. Scientists need publications. They need to think in more rigorous ways, you could say, and societal actors have different needs and expectations that don't always align. So these are challenges that we encounter. And then the second hypothesis that I mentioned, that all of this work that we do is going to contribute to agroecological transformation. And in the literature, we see that there's actually a tendency often of these types of efforts to reproduce the problems that they try to solve. So rather than putting our efforts on this spectrum, we're using this as more of a tool to foster discussions about the efforts and interventions that we make in the project, and to see, are we contributing to optimization and preservation of the system? So in ways that don't really address the underlying problems that we want to solve, or do we contribute to building a fundamental alternative to the existing system? And we use this as sort of a heuristic then to talk about transformation strategies. And one thing that we are focusing on now a bit in structuring some of the discussions is this idea of structure versus agency. So what are the things that are caused by social structures that agents or actors, individuals and small groups of actors cannot change on their own? What problems require collective action? And then how can these desired changes be realized? So these are just some of the discussions that we're having now. And next week, we'll go to Bulgaria for another co-innovation workshop and continue this. And would encourage everybody to check out the paper when it's published. And we'll hear more about a specific task in the project next from Adrian, or a bit later, to see how this way of working is applied to a research task. So that's it from me for now, and thanks everyone for your time.
Well, thank you so much, Stephen, for a very insightful talk on getting people into eco-hubs to train them, learning cycles, and for generating knowledge and the transformation strategies that you're adopting. So thank you for sharing all your innovative work with us.
Thank you.